Hello and welcome to this lesson on enabling the Global Order Promising Solution or GOP. In this lesson, we'll talk about the benefits of using the database-centric architecture for global order promising. We'll describe when and how the memory resident and database-centric architectures will coexist. We'll explain some of the enhanced capabilities supported through the database-centric architecture. And we'll see how to enable the database-driven architecture as well as administer and use the troubleshooting framework. So with that, let's get started by looking at the benefits, setups, and key details of the latest GOP architecture. The latest GOP architecture offers a variety of benefits, the most significant ones being that the new architecture offers more scope for scaling up by processing more number of demands per hour at peak times. Due to its database-centric nature, with this architecture, there are fewer opportunities for failure. Due to its parallel processing characteristics, changes to supply data like on-hand data or static setup data like ATP rules and so on can be recognized in GOP as soon as they are made available in the planning tables. This architecture also offers a simple troubleshooting mechanism to analyze the GOP promising results. The GOP solution supports a full range of order promising features either through the database-centric architecture or by redirecting orders automatically to the memory resident solution. While the order promising solution based on the database-centric architecture can be implemented out of the box for several business flows, more features would continue to be added in forthcoming releases and reliance on the memory resident solution will gradually diminish. All new product enhancements will be carried out by keeping in mind the database-centric architecture. While database-centric architecture can be implemented immediately for businesses that rely on end item promising and CTO model promising based on buy and transfer sourcing or internal material transfer business flows, as well as promising based on supplies like on-hand and scheduled receipts, as well as dropship-based business flows. Forthcoming releases will introduce new capabilities in the area of supplier capacity and back-to-back promising. Advanced features like planning integration, demand class-based allocation, as well as manufacturing support for both standard items as well as CTO models that consume materials and resources will also be added in future releases. The database-driven architecture is enabled using a seeded profile option MSE-enabled GOP with new arc. No additional setup steps are needed, and with this setting, the order promising solution will use the database-driven architecture to promise orders wherever possible. An order promising options page has been introduced, which uses some parameters for fine-tuning the database-centric architecture. For demands that need to continue to be promised on the memory resident order promising solution, the database-centric architecture offers a seamless way to redirect such orders to the memory resident solution without any external user intervention. The redirection of orders for promising to the correct GOP engine is achieved through an automated pre-processing mechanism that utilizes item characteristics and setups such as plan integration, as well as some ATP rule settings and so on to determine the right promising solution to process incoming requests. This process is completely managed internally by the order promising solution without any external user intervention needed. The promising results would continue to be made available to the order management system, similar to the earlier behavior. The database-driven architecture offers significant advantages in promising quality, especially during unforeseen failures. It also supports the ability to increase or decrease the number of promising instances proportionally to the load of order requests. All the active promising instances process incoming order requests in parallel, and these instances integrate with the database tables and maintain cached data for improvement in promising throughput. Multiple promising instances can be spawned in an application server, and the number of such application servers can be enhanced depending on the hardware configuration. A data locking mechanism ensures mutual exclusion in cases where multiple promising instances have to concurrently access and modify the same cache data. Each instance uses different options to acquire logs, update data, and release logs. The significant order promising business flows for which orders are directed to the memory resident GOP solution are back-to-back flows, which are driven using the back-to-back item attribute indicator. Items which are manufactured using the make CTP capabilities in GOP, which are driven using the search components and resources flag on the ATP rule. Items which are assigned a planning allocation rule and use the respect allocation constraints parameter on the ATP rule. And some other scenarios which include plan integration or profitable to promise and ATP time frames and so on. So with that, let's quickly look at how the database-centric solution can be used to quickly and optimally promise orders. So this is an instance which has an order which is currently being promised late. The order is promised late since there is insufficient supply available in the system to promise this order on time. Now, what we can do here is to quickly see how the order promising solution can reflect the new supply that comes into the system and see how it can do that without having to run the GOP server restart process. So first, let's see what the current behavior is and current results are. So as you can see, there is quite a lot of delay on this order. It's an order for quantity 300 units, and there's quite a lot of delay on this order. So now let's just quickly go and check what the item supply looks like. For that, we'll go to the global order promising work area. We'll go to review supply availability report. We'll query for this item. We'll see how much supply is there in the organization. As you can see, there's a quantity of 280 units available. The order is for 300 units, and as a result of which the order is delayed. Now there is supply available, which is being newly introduced in M1. This supply needs to be collected over. So for that, let us go to the collect planning data page in order to collect this new supply. We'll apply a filter to collect the supply supply data from M1. We're only interested in collecting supply data. We select the on-hand entity and we submit the job. Okay, so now the job for collecting the data has been submitted. We'll come back to this while collection runs in the background. In the meantime, we'll continue with our lesson. Let's now talk about some of the enhancements that have been carried out to support CTO dropship and buy related flows. So for CTO and buy related flows of configure to order items with this database centric architecture, the specific option level lead time calculations are taken into consideration while promising using both dropship and buy flows. And in such cases, the lead time consists of the sum of the lead times of the most constrained option as well as its parent model. And these are rolled up at every level of the CTO item structure. So the auto promising solution now recognizes that different options of CTO model configuration could have different lead times based on their supply availability or constrained nature. And depending on which options are chosen by the user while placing an order, the lead times could vary for dropship as well as purchased CTO models. For example, in case of a dropship model, which has a lead time of 5 days and has a couple of option classes with associated options having lead times of 2 days and 1 day respectively. The total lead time would be the model's lead time as well as the maximum of the lead times of the selected option items. So in this case, it would lead to um, a total lead time of 7 days by taking into consideration the top level model's lead time of 5 days and the option items lead time of 2 days. In a similar fashion, for a purchased CTO model, the total lead time would be the sum of the lead time of the purchased model as well as the maximum lead time of the selected option items. So in this case, it would be a total of 5 days, which includes a 4-day lead time for the selected option item added to the 1-day lead time of the purchased CTO model item. In dropship cases, for all constrained option items, the approved supplier list lead time or ASL lead time or the processing lead time are rolled up to the parent level model. The processing lead time is used only when the supplier lead time is not defined for the item in ASL. For purchased models, both pre-processing lead time and post-processing lead time are considered. For all constrained option items of the purchased model, the ASL lead time or processing lead time is rolled up to the parent level model. Processing lead time is used only when the supply lead time is not defined for the item in ASL. Lead time precedence is given to the configured items lead time defined in the ASL. And this is followed by the ATO models lead time, which is defined in the ASL. And then that's followed by the ATO models processing lead time defined in the dropship validation organization for dropship cases. And in case of ATO models which are purchased, the processing lead time defined in the receiving organization will be used. The ATO model's pre-processing lead time defined at the dropship validation org is considered for dropship flows, and the ATO model's pre-processing lead time and post-processing lead time defined at the receiving organization are considered for buy flows. The pegging details show the lead times that have been calculated when GOP promises the configuration. For dropship cases, the pre-processing lead time value is shown as the pre-processing lead time of the dropship model. The processing lead time would be the sum of the processing lead times of all the constrained items rolled up to their parent level models and summed up for each level of the CTO item structure. In cases of purchased CTO models, the pre-processing and post-processing lead times would be shown for the purchased CTO model, and the processing lead time is again similar to the earlier case, and it will be the sum of the constrained option lead time and its parent model, which is rolled up at every level of the item structure. The lead times are calculated based on the calendar working days in the supplier calendar defined in ASL for the top level model only. And if this calendar is not defined, then in case of a dropship flow, the dropship validation organization's calendar is taken into account. And if this is a purchased CTO model flow, then GOP will just use the fully open calendar if the supplier calendar is not defined for the top level model. Now let's look at some of the administration and troubleshooting related aspects of the database driven solution. In order to smoothly manage the administration of day-to-day order promising activities on the database-centric architecture, a set of parameters and settings are available in the order promising options page. Default values are assigned for all the settings and parameters, and these are optimized for a majority of business flows. And in case any changes are needed, they can be made with the guidance of the product team, and in case any fine tuning is required, the parameters can be suitably adjusted. So let's take a look at some of the main parameters that are included in this new page. The first one relates to the locking options, which tell GOP how to wait for inventory locks and how to manage the wait times and how often they should retry for accessing those inventory locks in case of concurrent requests coming in for the same item supply. The second important area relates to time zone options, where you can set the time zones for customers and suppliers default value in case they're not provided in the data. The third section deals with the troubleshooting framework and how to enable it, and we'll talk through it in a little more detail in the coming slides. So in certain conditions, it may be necessary to understand the context within which one or more orders are promised by GOP. The troubleshooting framework built into the database-centric architecture, which is called the replay framework, allows for replicating such scenarios and provides additional insights on the conditions that existed at the time of the order promising. This is helpful for the development team to carry out root cause analysis and provide explanations on the promising behavior. In some of these cases, some of the typical cases that we can see where this mechanism will facilitate root cause analysis are when unexpected scheduling results are observed, and the replay framework can then help in getting insights into the conditions that gave rise to the observed behavior. Let's say GOP promised an order without taking into consideration some supply that was expected to have been available, but was actually consumed earlier by a different demand. The other possibility is when you want to further understand promising constraints like insufficient input information available for GOP to promise, or how GOP promised when certain boundary conditions came into being. And the third case is one where there are unforeseen events or potential exceptions. This framework can help trace the conditions that led to the unexpected behavior, and it can provide additional insights into that behavior. The troubleshooting mechanism is available for cases that involve order scheduling, such as check availability, schedule sales order, and auto schedule flows. The steps that are needed to carry out the troubleshooting flow are that you need to enable the replay framework in the order promising options page, like we saw previously. Once that is done, the same steps that caused the unforeseen behavior can be replicated, and the same results can hopefully be seen. And in such cases, the GOP engine will write out some additional information into its logs and save that in the database tables. Once the steps have been successfully executed, this additional troubleshooting information needs to be extracted. For that, the schedule process extract global order promising replay data can be used. Once this schedule process is invoked, certain parameters can be given, such as request type, request date, user, sales order number, and replay key. This is to correctly identify the troubleshooting information that has been logged, and for the GOP engine to extract the most relevant troubleshooting information. Once this job is submitted, it will create a zip file which can then be downloaded into the local machine, and this zip file can then be provided to the product support team or the development team for further analysis. And as a final step, you need to return to the order promising options page and switch off the troubleshooting framework parameters so that normal promising of orders can resume. So with that, we'll come to some of the considerations for enabling GOP with the latest architecture. The database-driven architecture can be used exclusively out of the box for business flows that require end-item-based promising with buy and transfer supply sources, or dropship-based business flows, especially for configure-to-order items. Promising flows involving infinite availability or lead time based promising, or supply chain availability search based promising without component and resource checks. All these are supported out of the box in the database centric solution. The memory resident solution can be used exclusively in cases where manufactured items need to be promised by consuming materials and resources, or back-to-back flows need to be promised, or there are items which have supplier capacity or have other features like plan integration, ATP time fence are profitable to promise. So all these need to be exclusively promised using the memory resident solution. In majority of the businesses which have a combination of these requirements, they can be still achieved by enabling the new architecture profile option, where the order promising solution will seamlessly switch over to the memory resident GOP solution whenever it sees the order for an item which needs to be promised by the memory resident solution. Now let's talk about some of the aspects which need to be kept in mind while promising in any of these modes, especially from a day-to-day operational point of view. If the items are to be promised exclusively through the memory resident solution, then the profile option MSC enable GOP with new ARC can be set to no. Refresh and start the order promising server and the start real-time supply update schedule processes can continue to run as before. The order promising options page will not be available in such cases, and in order to troubleshoot any particular order or any particular behavior, the input-output payloads as well as the GOP data store would need to be provided to the support or the product development teams. In case a solution is implemented which uses both the flows where the certain proportion of the orders are promised using the memory resident solution, whereas others are promised using the database-centric solution. The profile option MSC enable GOP with new ARC can be set to yes. Refreshing and restarting the order promising server and the real-time supply update schedule processes would still be need to be enabled. The order promising options page would be available to fine-tune the parameters of the database-centric architecture-based solution. In order to troubleshoot, you would need to provide the input-output payloads, the GOP data store, as well as the replay data for the support and development team to analyze and provide a root cause analysis to any troubleshooting related questions. Now, if the business flow can be exclusively promised using the database-driven architecture, then the profile option MSC enable GOP with new architecture can be set to yes. Refresh and start the order promising server as well as real-time supply update schedule processes can be set to no, and these need not be run on a regular basis, on a daily basis. The order promising options page would be available for fine-tuning the parameters of the database-centric architecture. And in order to troubleshoot the GOP behavior, the input-output payloads as well as the replay data can be provided in this flow. In all flows, both REST and SOAP public web services would be available for carrying out API-based calls. A few points to note related to the new profile option are that in the event that the profile option is inadvertently turned off, and assuming that the refresh and start the order promising server has been periodically running and has been running on a daily basis, there will be no impact on order promising, and order promising will continue as before in previous releases, and orders will continue to be promised using the memory resident solution. So now we've come to the end of this lesson. We've talked about the benefits of using the database-centric architecture for global order promising. We've described how the memory resident and database-centric architectures will coexist. We've explained the enhanced capabilities supported through the database-centric architecture and seen how to enable the database-driven architecture as well as administer and use the troubleshooting framework. So let's quickly go back to our environment and see what the result for the same order is. So we had previously just run collections, and we had seen that there was insufficient supply for this item. And as a result of running collections, we now have sufficient supply for the item, and now we'll just rerun the check availability call to see that the order has been correctly promised on time without any delay. Now that the supply has been collected over, GOP has seen that new additional supply is available, and it is able to promise the order on time without any delays. Now, this has been carried out without any GOP restart, and this shows that the new database-driven architecture is capable of carrying out your day-to-day promising with minimum overheads and minimum operational inefficiencies. So with that, we come to the end of this lesson. Thank you for listening.